Hey, hello there. Today's Leetcode challenge question is called surrounded regions. We have a 2D board containing two kinds of values, x and o. The regions of the o's can be considered as captured if they are surrounded by the x. So for all those regions that are captured, we want to flip those o's into x. So looking at the example, we have a 4-row 4-column board. It's obvious that the middle three o's are surrounded by the x, so we have to flip those values into x. So as a result, this is the output board. Note that on the bottom here, the O that's connecting to the outside world are free. It has infinite amount of space it can run away from those approaching X. So this one is free. So not just only this O's on the board, on the boundary are free. Any O that can connect it to a O on the boundary can be considered as free as well. So any O that has that's reachable from the boundary O can be considered as safe as well. So that leads to pretty much the way to solve this problem. We're just going to look at the four boundaries, and whenever we see a O, we try to do exploration from that O. Any O that's reachable through this boundary O, we're just going to mark all those as safe. And once we've done this marking, we just do a second pass for the cells on the board. If it's O and it's not safe, we just do the flip. Otherwise, we just continue. So it will be a two-pass algorithm. One pass to mark those safe O's, and the second pass is to do the flipping. So the runtime is linear with respect to the board size. The space to store those safe positions are linear as well. So that's pretty much it. For the actual exploration, we could either do DFS or BFS. There's not really any difference between those two in this case. So yeah, let's just start code this. It's easy, very straightforward problem. Just that the code can be a little bit more. So yeah, let's code up. So what we want to do is to mark the positions as safe. So this is marking, and then we're going to do a flipping. So the marking is we try to explore the reachable O's from the boundary. So we're going to enumerate over the boundary positions. I guess there could be smarter ways of doing this. My code is going to be looking a little bit messy. So we're looking at the left and right now. And once we're done with the left and right, we do the top and bottom. The code is going to be the same. It's just going to check if this value is a O, so this R and row number, column number is the O on the boundary, and we haven't explored it yet. So that's the marking part. We're going to code the function shortly after this. The flipping is just going to enumerate over all the position one more time. Oh, I can just copy that and do a very little modification. So just after we do the marking, we try to look at all the positions. If it's O and it's not safe, we do the flipping. So that's pretty much the main part. The only thing left to do is to do this search, the graph search, traverse. It's not search. So yeah, let's just do DFS search. So we got a stack Initially, you only have this initial position. So if it's visited and marked as safe, we continue. Otherwise, we add this into the safe and then start to explore the 4 adjacent locations. If it's a valid location and also the value is O, we add this, we push this onto the stack. It's going to be the next position we will explore. So that's check whether it's a valid position. Yeah, so that's pretty much the code. Let's see if it works. Runtime error. Okay. Okay. I should add the tuple. Anything else? Alright, it looks nice. The middle 3 are changed, but the boundary one is remained safe. I'll just submit this one. Yeah, it's accepted. Yeah, there's it's pretty straightforward. Just quite a lot of code to type in. But in terms of difficulty, this is pretty simple. Yeah, so that's it for today.